Have you ever seen one of those colossal cargo ships, basically a floating city made of steel, and just wondered, how in the world does that thing float? Well, today we're going to crack that puzzle, and the secret, believe it or not, is thousands of years old.
All right, so let's jump right in. The whole thing really boils down to this one paradox, something that just doesn't seem to make any sense at first.
I mean, really think about this for a second. We're talking about a ship that can weigh 500,000 tons. It's made of steel, and then you have a tiny little steel nail you could hold in your fingers. The ship floats, but the nail sinks like a rock. What is going on here?
So you've got the nail sinking and the ship floating. Same exact material, but a totally different outcome. This is the big mystery we're about to solve.
Okay, so the very first piece of the puzzle is this invisible force that's always at work whenever something's in a fluid. And, that means water or even the air that's all around us.
And that force has a name, buoyancy. And you've definitely felt it. You know when you get into a swimming pool and you suddenly feel way lighter? That's buoyancy. The water is literally giving you an upward push, fighting against gravity for you.
So, where does this push even come from? Well, it's not magic, it's just basic physics. The deeper you go in water, the more pressure there is. So for any object that's in the water, the pressure pushing up from the bottom is always stronger than the pressure pushing down from the top.
And that difference in pressure, well, that's everything. It creates a net upward force. And that is buoyancy, plain and simple. The water is always pushing up more than it's pushing down.
Okay, so we know there's an upward push, but how much of a push? How do you even measure it? Well, lucky for us, a super smart guy from ancient Greece named Archimedes figured it all out.
And this is it. This is the secret right here. Archimedes' principle. The buoyant force pushing up is equal to the weight of the fluid that the object displaces. Let me say that again, because this is so important. The upward push an object gets is all about the weight of the water it shoves out of the way.
So picture this. The bigger the hole an object makes in the water, the more water it has to displace. And the more water it displaces, the bigger the upward push it gets from all that water trying to rush back in. It's really as simple as that.
All right, now we have the golden rule. So let's put it all together. It's time for the great float-off, nail versus ship.
So what's really happening here is a constant battle, kind of like a tug of war. You've got the object's own weight, powered by gravity, pulling it straight down. And on the other side of the rope, you have that buoyant force pushing straight up. And there are only three possible outcomes to this fight. 1, if its weight is stronger than the buoyant force, the object sinks. 2, if the forces are perfectly tied, the object just kind of hovers in place. And 3, if that upward push from buoyancy is stronger than the object's weight, you guessed it, it floats. Okay, so back to our nail. It's dense, it's solid, it barely displaces any water at all. So the buoyant force it gets in return is super, super weak. Its own weight just completely overpowers that tiny little push. The tug of war is over before it even starts. Down it goes. Every single time. But the ship, the ship is playing a completely different game. Its secret weapon isn't the steel, it's the shape. A ship is basically a giant, hollowed-out bowl. It's engineered specifically to push a massive amount of water out of its way. And because it displaces a huge volume of water, it generates a huge buoyant force pushing back up, a force so huge it perfectly cancels out the ship's entire incredible weight. The tug of war is a tie, and that's why it floats. It's not magic, it's just brilliant engineering.
So now that we've solved the mystery of the floating ship, you are going to start seeing this principle everywhere. This one simple rule is at work all around us in some pretty surprising ways. Ever wonder how fish just hang out in the middle of the water? They have a little internal gas bag called a swim bladder that they use to perfectly adjust how much water they displace. A hot air balloon is just floating in the giant fluid we call our atmosphere. And why is it so much easier to float in the salty ocean than in a freshwater pool? Well, salt water is denser, so it provides a stronger upward push.
And this isn't just about fun facts. This principle has some really serious real-world applications. You see that weird symbol with all the lines on the side of a cargo ship? That's called a Plimsoll line, and it is literally a life-or-death application of Archimedes' principle.
See, those lines tell the crew the maximum safe depth to load the ship depending on the type of water it's in. Because salt water gives more lift than fresh water, you can actually load a ship heavier in the ocean than in a river. If they get that wrong, if they overload the ship, buoyancy loses the tug of war, and the whole thing goes down.
So there you have it. The secret isn't about what the ship is made of, it's about its shape and its ability to displace enough water to fight gravity to a draw. Now that you can see this invisible force at work, here's my question for you. What's something in your own life, something that floats or sinks, that now makes perfect sense?